We are taking R.D. Sharma Solutions, Class 10 Maths, Chapter 15, Exercise 15.4. In this figure, the boundary of the shaded region consists of 4 semicircular arcs, 1, 2, 3 and 4. The smallest 2 being equal. So these are equal. If the diameter of the largest is 14 centimeter, from this point to this point it is 14 centimeter. And the smallest is 3.5 centimeter. The smallest one, this is 3.5 centimeter. Find the length of the boundary and the area of the shaded region. So first we will find out the boundary of the outer one. That is, this is the first one, this is the second one, this is the third one, and this is the fourth one. So what is the length of the boundary? Because we know that the circumference of a circle is 2 pi r. And the circumference of the semicircle is pi r. So we have to take pi outside and take r1, that is the radius of this one, which is 14 by 2. So 7 plus, I am taking pi r1 plus pi r2 like this. So I am taking pi out. The r is for the first one. Let us come to the second one. The 7 is the radius, so 7 is the diameter, so radius will be 7 by 2. Then coming to this one, this is 3.5. 3.5, what is the radius? 3.5 by 2. So 3.5 by 2 plus 3.5 by 2, that is, there are 3 and 4, so I'll just multiply this with 2. Okay, so this is, again, this 3.5 can be written as 7 by 2. This is again 7 by 2 only. So 7 by 2 plus 7 by 2 is 7 only. 7 plus 7 is 14. So what do you get? 14 pi. 14 pi and 14 pi, so 22 by 7 into 14, 7 to the 14, 44 you get. So 44 is the perimeter, you can say, of the boundary. Now coming to the area. Area is what? For a semicircle, the area is pi r square. So same thing we'll do. Pi will take out. Oh, let me tell you first what we have to do. First we'll take the area of the first one, area of the second one. Then we'll subtract the area of 3 and 4. Area of 3 and 4. So that is essentially equal to 1 plus 2 minus twice of 3, because 3 and 4 are exactly similar. So what is the area of the semicircle? Area of a circle is pi r square. Area of the semicircle is pi r square by 2. So what we can do here is we can take pi by 2 outside, and we can just deal with the radius. So what first radius is how much? This is 14. So it is 7 square plus, now second one, this is the radius is 7 by 2, so you have a 7 by 2 whole square, that is 3.5 whole square, minus 2 into, why I am doing 2, I am taking these two together because they are exactly same. So radius is 3.5 by 2 whole square. Okay, when you compute it, put pi equal to 22 by 7 and you get the result as 86.625 centimeters square. In this figure, AB, this AB is 36 centimeter, M is the midpoint of AB. Semicircles are drawn on AB. This AB, AM and MB. A circle with center C touches all the 3 circles. Find the area of the shaded region. So by symmetry, one thing has to be noted here is, what is the diameter? Because this we already know. From here to here it is 36. From here to here it is 18. But how about this one? So because of this symmetry, if you see that this is one portion, this is another portion, this is another portion. So this is basically, if I just join this, these are 3 parts, 1, 2, 3. So 36 is the length. So if you divide it by 3, so we get 12. So this is the diameter. 12 is the diameter of the inner circle, this whole circle. So in order to find out the area of the shaded region, first we will find out the area of the semicircle, that is the bigger one, that is this one. Then we will subtract this 2 and 3, which are exactly similar, and this 3. So 1, this 4. So 1 minus 2 minus 3, this area, minus 4. So what is the area of the first one? We know that the area of a semicircle is pi r square by 2. So pi r square by 2, pi by 2 r square. What is the radius of this one? This is 36, so radius is 18 square. So it will be 18 square. I will take pi by, no, I will not take pi by 2 because pi will be coming here. So it will be pi by 2, 18 square, minus. Now twice into, why I'm doing twice? Because 2 and 3 are exactly similar. So 2 into pi by 2 into r square. What is the radius of this? This is 18. So radius will be 9 square. Now subtracting this one. As I said, the radius is what? 1 by 3rd of 36. I explained you how, 12. So this will be 12 and the diameter is 12, so radius will be 6. So it will be, again it is a circle, so I'll take full pi r square, pi into 6 square. Okay, if I just compute this, this is going to be, if I just take this pi by pi like that only, if I don't multiply pi, it will be 45 pi. You can write it like this, centimeter square. In this figure, ABC, this ABC is a right angle triangle in which this angle A is 90 degree, AB is 21 centimeter, AC is 28 centimeter. Semicircles are described on AB, AC and BC. So we have this one, and this one. Find the area of the shaded region. So how we have to do it? First of all, we have to because this region can be only found when we take the area of, we have to take out certain areas. First we have to add 3 areas, then subtract the third one. Okay, we have to find out the area of the shaded region. So for that, first of all, we have to compute the area of, first of all, we have to find out this length, because this is 21 and this is 28. This is not known to us. So this length will be 21 square plus 28 square. I'm using the Pythagoras theorem. And this is going to be 35. This is going to be 35. So what is the area of, I'm just giving the names. So let us say that this is the longest one, or you can say the highest area one. Semicircle is 1. Then we have the area of the second one, then third one, and then we have a triangle, fourth one. So what we will do, first one, the area will be, what is this? This is pi r square. With this we have to, this area we have to find out, means the shaded region. So first we will find out the area of this first one, which is pi r square by 2. So pi r square by 2. What is the radius? See, this is 35. So it will be 35 by 2 whole square. Now the second one, which is this region, it will be pi by 2 into, now this is 21. So radius will be 21 by 2. Pi into 21 by 2 whole square. Okay. Then the third one, which is this one. So this will be pi by 2 into, what is the diameter is 28. So we'll just take 28 by 2 whole square. This is the radius. Okay. Now what we have to do here is, we have to add this one, first one, second one, the second one, and third one. No, second one we have to subtract. Please understand, second one we have to, this 35 by 2, this one has to be subtracted. So what we will do here is, this means this whole area plus this whole area, this we'll find out, we'll add them. Then we'll add the area of the triangle. Okay, then we'll subtract this area. I hope you got the idea. So what is the area of the triangle? Let us say half into base into altitude, that's 21 into 28. So what I'm trying to suggest here is, first we'll take the area of the fourth, that is second part, which I just said. Then we'll take the area of third, means this one, and we'll take the area of triangle, which is fourth one, and then the center one, which is the first one, has to be subtracted. This is what we have to do. Okay. So we have these all. So let us just add them. For pi by 2, pi by 2, pi by 2, we can just take outside. So we have to add 2, 3, 4. So we have 2, that is 21 by 2 whole square, and then 3, that is 28 by 2 whole square, and then we have this 35 by 2 whole square. This has to be subtracted, so I'll just say minus 35 by 2 whole square, and then we have this has to be added. So I'm just taking 1 here, this one is 1. Then we have the area of triangle, that is half into 21 into 28. So here is a very interesting thing, that when you take pi by 2, and this 21 by 2 whole square will be 441 by 4. This will be 28 by 2, so it will be 14. 14 square is 196, and then we have, this is 35 whole square, 1225, 25 by 2 by 4. So if you see, if you compute this, this hole is going to be this addition, and this addition will be 1225 minus 1225 pi by 2. So this is eventually going to be 0. See, this will be going to be 0 ultimately. So only we are left with the half into base into altitude, which is going to come as 21 into 28, which is 294, and this is nothing but the answer. So this is the region we are talking about. So what we did, let me tell you again. We took this one, and this one. So 1, 2, 3. We just added them, and then we subtracted this first one, that is this one, from here. So we got this area, these two areas. In the figure shows the cross section of railway tunnel. The radius of OA of the circular part is 2 meter. If angle AOB, this is 90 degree, find the height of the tunnel. So we have to find out the height of the tunnel and the perimeter of the cross section and the area of the cross section. So here is the figure, how we are going to do this. First of all, this OA and AB, it is given that it is 2 meters. So radius is 2. This is 2, this is 2. Now when this is 2 and 2, and this is 90 degree. This is 90 degrees. So by Pythagoras theorem, we can use this. We can find out AB. AB will be simply equal to 2 square plus 2 square under root. That is 2 square into 2. So 2 comes out, 2 root 2. So what do we get? This AB as 2 root 2. Now when we drop a perpendicular here, if this AB is 2 root 2, what this will be? Root 2, and this will be root 2. Half of this. So half of this will be this one. This is half. Now in this triangle which we are getting, this is 2, and this is root 2. So what this side will be? Again Pythagoras theorem, root 2 whole square minus 2, this 2 whole square minus root 2 whole square. So 4 minus 2, that is going to be 2. And when we find out the root, it will be root 2. So this one is root 2. This one is root 2. So this is 2 because it is a radius, and this we just found out to be root 2. This is 2, and this we just found out to be root 2. So the height will be 2 plus root 2. So the height will be 2 plus root 2. Now the perimeter of the cross section. For that we have to find out this one plus this one. This one plus this one. AB we already know. So AB plus the major arc we have to use. Major arc. That is ACB, if you can say. So this major AB is already known to us, which is this one, which is already found to be 2 root 2. So 2 root 2 plus major arc. Major arc is what? See, this angle is 90 degree. So what this angle will be? It will be 270 degree. 360 minus 90 will be 270. So what is the length of the arc? Any arc of a circle is theta by 360 into 2 pi r. In this case, theta is 270. So 270 by 360 into 2 pi r. That is 2 into pi into r. What is the radius? 2. And 270 by 360 is nothing but 3 by 4. So 3 by 4 into 2 pi into 2. So 2 to 4, you get 3 pi. So just add 3 pi here. So 3 pi by 2 root 2 is the whole length from here to here. So it's a boundary. So the perimeter of the cross section is this. Now in order to find the area of the cross section, what you have to do? You have to find the area of this sector and area of this triangle. And since this triangle can easily be found out using, because there is a triangle here and this is 90 degree. So this one, 2 and 2, half into base into altitude. This is base, this is altitude, because this is 90 degree. So half into base into altitude plus the area of the sector, which is this one. So area of the sector is what? Again, 270 theta by 360 into pi r square is the area of any sector. Theta here is 270 because we have to find out this one. This area I'm interested in. 270 by 360 into pi r square. The 270 by 360 is 3 by 4 into pi. That is, you can use pi directly. And r square radius is 2. So 4. 2 square is 4. So what do you get? You get 2 plus 3 pi. 2 from here, 3 pi from here. This is the answer. In this figure, it shows a kite in which BCD is the shape of a quadrant of a circle of radius 42 centimeter. Now ABCD, this ABCD is a square, and this is a triangle, isosceles triangle, right angle triangle also, because this is 90 degree. Whose sides are 6 centimeter long, so the sides are also given. Find the area of the shaded portion. So what we have to do, this is the first area, this is the second area, we just have to add these two areas. So what is the area of the quadrant? It is 1 by 4 pi r square. Theta by 360 into pi r square. Theta is 90 degrees, so 90 by 360 into pi r square, 1 by 4 pi r square. So 1 by 4 pi, that is, you can take it as 22 by 7 pi r square. What is the radius? What is the radius here? It is being given to us, which is 42. See, 42 is the radius. So 42 into 42. This is the first one. And now how about the second one? Because it's a 90 degree, and we know that these sides are 6 and 6. All the sides, these two this is an isosceles triangle. This side is 6, this side is 6, and this is 90 degrees. So half into base into altitude. So half into 6 into 6. This will come as 1386. This will come as 18. So the answer will be 1404 centimeters squared. Now this question we are going to take in the next discussion. Till then, thank you so much. Take care of yourself.